Hello and welcome to another video from oorail. In this video, we're going to continue our Class 66 project as part of Loco Works Wednesday. This is part 4, and today we're going to show you how to wire up and how to test the lighting circuit in this Class 66. As you can see here, I've got some pretty crazy wiring stuff going on and some breadboards that are blue tacked to the chassis of the Class 66. This is a pretty cool way to test the Loco as well as test other electronics. And you can see I've got it wired into the Dcc socket right here, and I've removed the Dcc plug, essentially creating my own sort of hybrid lighting slash Dcc plug. So what I'm going to do right now is cut over to showing you this actually working on the layout, and then what we'll do is we'll have a somewhat lengthy video where I explain exactly how I did. Alright, so I hope you enjoyed checking that out in the layout and seeing that it worked pretty well. And so in next week's video, we'll actually get it inside the Loco and all soldered up and so on. But today what we're going to do is show you exactly how you can build this and test things around electronically in your Loco. You don't have to use a Class 66. This will work with any Loco actually at all. You don't need to necessarily have the DCC plug, but having the DCC plug here or socket does make it a lot easier in terms of wiring and so on. I'll show you how to use the multimeter to basically figure out what pins are connected to each other, as well as reverse engineering the socket a little bit, or sorry, the plug. And I'll also explain to you exactly how the circuits work and so on. So before I get into that though, there are a couple of components that you're going to need, and I wanted to show you how to do that first and kind of explain what they are. And the other thing is, in this video, everything we do does not involve any kind of soldering whatsoever, so you can do all of these electronics with very simple tools and breadboards, so it's a very good way to prototype. Alright, so before we get started, everything I'm going to show you here you can get from Amazon or your favorite electronics store or whatever. To make life easier, what I'm going to do is everything that I've used here, I've pretty much bought off Amazon. So what we're going to do is put it in our Amazon UK as well as our Amazon US store. You can find a link in the description below, and if you want to buy from there, that's great. They kick me back a few dollars when you guys buy stuff from there, and it helps fund the channel for other kind of cool projects. But you don't have to order from there. If you want to order from somewhere else, that's totally up to you. But I did put it there mainly for your convenience rather than for me making money, because it's only a couple of dollars. So what I want to do next is basically walk you through a couple of different components and explain what they are. I'll do this later on in the video in a little bit more detail, but I just want to give you kind of a quick rundown so you know what we're using. So the first thing we're using is a breadboard, and these are micro breadboards, and they're still a little bit smaller. We have bigger ones. Which I have right here. So we have a much larger one. Obviously this won't fit in the Loco, so we're not using that. We're going to use this little one. So it's pretty straightforward, and with the micro, basically I'm going to use the screwdriver here to show you. Basically these pins, or these socket holes here in this line, so 1, 2, 3, 4, 5, these 5 are connected together, and then these 5 are connected together. So if you want to connect these to these, you'd have to jumper a cable across between the two, and then each row here is independently wired to each other. So this is not wired to this, but this is wired to that. This is not wired to this, but this is wired to that. That's not wired to this. So it's pretty straightforward. Just the ones here in the bank on the other side of the slit are wired together. So each kind of half row is wired together. And so what you can do is you can plug your electronics in and then use jumper cables between those to basically hook things up. And it's pretty straightforward. you can get jumper cables in a pack of like 100 or so, and basically what they are is they're kind of a rigid, pointy, solid core wire on either end, and these fit into the breadboard. So if I take the breadboard and I want a jumper, say that to that, now anything that's in these remaining pins here will be connected to these remaining pins here, and it makes life a lot easier. Another thing that you're going to need are resistors, and so in today's video I'm actually using 3 types of resistors. I'm using a 1 kilo ohm resistor, a 150 ohm resistor, and a 470 ohm resistor. So you can tell here from looking at the colors what kind of resistor it is. You can plug those into a resistor calculator and it will tell you what the value is. A long time ago I used to know how to decode these because I did it at college, but it's been quite a few years since I've been in college, so I just used resistor calculator. It's a lot easier. So the reason I'm using 3 different types, I'm using the 1 kilo ohm, which is this one right over here. I'm using that to protect the circuit, kind of drop the current over it. And then I'm using the 471 to make one of the marker lights a little dimmer than the other, and the 150 ohm one is to make the other marker light slash headlight a little bit brighter because it's got the headlight associated with it. So basically what a resistor does is it kind of restricts or reduces the flow of current through the circuit, and the effect that has on the LEDs is it basically makes them dimmer or brighter depending on the value of the resistor. So you can use the resistor to adjust the value as you need to. The reason we're using these is to basically protect on the forward voltage where the LEDs will light up. We're basically protecting them against having too much current and too much voltage going into the LEDs, because the LEDs are rated for about something like 2.5 to 3.8 volts and a couple of milliamps, whereas the train controller that's on the track, it can have an input voltage going into the train of anywhere from 0 volts to 12 volts or even 16 volts DC. That's another thing to keep in mind. All the circuits that are in this video are all DC circuits as well. If you're using DCC, it's slightly different. It is almost like an AC type square wave that's on the track. You may be able to piggyback off some of the pins off your decoder, but that might be a lot trickier. So I am going to leave that open to somebody else. If you guys do DCC and you do a video based on this, let me know, and I'll put a link to it in this video so people can find it. But for folks that are doing DC, this is definitely going to be useful to them. So that's what a resistor is. Okay, so for diodes, we used a 1N4005, and 1N4005 is basically a diode that can handle about 50 volts. And what a diode does, and this is a package of them, by the way, there's a whole bunch of different kinds. But you can see, bigger one right here. You can see there that there's a kind of silver stripe on one end. And so basically what happens is the flow of electricity coming on this side is blocked on the silver stripe side, while as it flows electricity okay the other way. So if I pull one off the circuit board here, you can I can just pull one off the circuit board. Maybe. So diode looks sort of similar to a resistor, but they do different things. So basically a diode allows for electricity to only flow in one direction, and what this does is it basically allows us to protect the circuit when the train travels in the opposite direction that the circuit is wired in. So when the train's traveling one way, power will go across the diode and it'll light the LEDs. When the train's going the other way, the diode will basically stop the flow of electricity, so it'll protect the LEDs. Now LEDs are a type of diode themselves, but we're using a diode to protect the LED, basically to stop any kind of over voltage. Now these things are relatively cheap. They come in big old packs of a couple hundred for a few dollars, and so they're a lot cheaper than the LEDs. And so the idea is that while the LED will kind of protect itself a little bit, putting one of these in the circuit will protect the LEDs from the voltage traveling in the opposite direction. Now, what's interesting is these ones are, like I said, rated for about 50 volts. The DC controller can only produce about 16 volts. So this is kind of overkill for the circuit itself, but the reason we've done that is these things are just a few pennies, like I said, each, and this will protect the LEDs, so we don't have to keep replacing LEDs if something bad happens. So it's an important part of the circuit. Alright, and then of course you've seen the LEDs that we've been using. I will dig one up here. So we're using these surface mount LEDs, and so they're really small. The gold wire is the positive, or copper colored wire is positive, and the silver colored wire is the negative, and they're the same length, so you can't use that trick, and they're way too small to see the plates, so it's kind of trial and error, just low voltage, see if it lights up, if not flick it around the other way. And you saw my last video, I had soldered those up to a board like this. I opted to go ahead and get the pre-wired ones. I could have soldered more of them, but I decided to go with the pre-wired ones because it's a little bit cleaner, and it'll save me from having to 3D print lenses as well. So yeah, so I wanted to get the project going a little bit faster, and I wanted to save my sanity with the soldering. Alright, so what I'm going to do next is basically walk you through each of the circuits, and then there'll be some more footage of it running on the layout, and then next week we'll show you it all inbuilt inside the train and working correctly, as well as wrapping up some of the 3D printing and bodywork on the locomotive. I do apologize, this video is a little bit late. I was hoping for some parts to come in so I could actually finish this evening for Loco Works Wednesday, but unfortunately Amazon said it was out for delivery and it actually hadn't really shipped yet. So it's one of the downsides of using Amazon Prime. Sometimes they get stuff out to you within 1 to 2 days. Other times their shipping partners aren't quite as efficient. So anyway, so in this video you'll at least get to see the circuits working, how to control them and how to test them on the train here. And if you have any questions, please feel free to put them in the comments. If you have any suggestions or ideas, let me know. One of the things that we're going to be doing, and one of the reasons why I'm showing you this, is that we're going to do some kind of cool projects once this Class 66 project is done, using a similar technique, and I think you guys might enjoy the results from that as well. We're going to do some pretty cool stuff over the next few months. Okay, so before we go and explain what each of these circuit boards do, I wanted to explain the goal again, just to remind folks, especially if you haven't watched the first 3 parts to the series. So we're adding lights to this train, but it's being used for the railhead treatment train. And so in the railhead treatment train, there's 2 locomotives involved. You have the leading locomotive that'll be on the head of the train, that'll be going forwards, and then you have the rear train, trailing train, that's basically bringing up the rear. And so the trailing train will have the rear tail lights on, whereas the leading train will have the front side markers, the headlight, and the top marker light as well. So what I wanted to do was create a circuit so that when the train was running in one direction, it would have the forward lights on, and then it was running in the opposite direction, it would have the rear lights on. And the reason for this is it basically means I can pick the train up and move it around on the track. So if it's going one way, I'll have the forward lights on. If I pick it up and do it, it'll still go in the same direction, but it'll have the rear lights on. And that way I can just pick a train up and turn it around depending whether I wanted the leading or trailing train. So I just want to make that clear before folks get really confused, because it would be a different wiring configuration sort of for doing. Okay, so this is really very simple. We have a crocodile clip here that's going to the track that's handling one side of the circuit, and then we have a crocodile clip that's going to the other rail that's handling the other side of the circuit. We have 4 breadboards here, and each one has a different part of the circuit. This breadboard here is basically just acting as a interconnect, so it's connecting the different circuits together. This one here controls the forward light, so it's controlling the headlight as well as the two side markers. It's not controlling the top marker. This breadboard here with this circuit is controlling the top marker, and that's all it's controlling. And then finally, this circuit here, or this breadboard here, is controlling the rear circuits. And basically, the electricity is going to flow from one side in through it and out through the other. So it goes through each of the circuits, but it's configured in such a way so that it only works the way we want it. Now, while LEDs are light emitting diodes, they only work one way. They block current the other way. And so normally you could just run these by themselves with a resistor, but because the voltage that's on and the current that's on the on the track is a little bit higher than tolerances for these LEDs, I decided to go and put some protective diodes in place. So there's a diode on this circuit and a diode on the rear circuit, and basically those are there to protect and block the voltage and current when it's going in the opposite direction. So when the power is going the reverse of what the circuit's supposed to be able to handle, and this diode will stop it. And then when the train's going the opposite direction, this one here will have electricity trying to flow through it in the opposite direction, and this diode here will block that. So those two are basically there just to protect our electronics. In terms of parts that you'll need, it's pretty simple. We have the 5 LEDs. We've got 3 warm white ones, and these are the SMD LEDs. I just decided to go with the pre-wired ones just because it's easier, and I thought I'd show you guys a couple of different options. This are the 2 SMDs that are red, and then we have a couple of resistors. I'll put the values upon the description. But basically we got 2 here which I think are 470 ohm, and then we got 2 here which I think are 1 kilo ohm. And like I said, the 2 diodes and some jumper wires. So once you've got the circuit all figured out, you can basically then either duplicate it or just take your components and solder them together the way that they were connected here on the board inside the locomotive. Alright, so what we're going to do next is we're going to walk through each of these circuits and explain how they work, and then explain how the whole thing works together. Okay, so here we have the circuit for the tail lights, and I'm going to basically use this to explain what's going on. So we've got 3 components that are used here on the circuit. We've got a resistor, we've got a diode, and we've got these LEDs, or light emitting diodes. So the diode and the light emitting diodes are very similar. Obviously the light emitting diodes emit light, while this is just a regular diode. And so what I'm going to do is explain basically what's going on here. So the diode is basically an electrical component that stops the flow of electricity in one direction. And so the direction it actually blocks the electricity from flowing in is denoted by this stripe that's right here. So electricity coming in through this wire and trying to go over the circuit this way would be blocked by this diode. Now the LEDs work in a similar way. They only work from positive to negative, and so a flow of electricity from negative to positive is blocked by the internal diode function of the LED. Now, the reason I have this diode here, because it might seem a little bit redundant, is basically to protect the LEDs. Because the voltage is variable coming from the controller, it can be anything from 0 volts to 12 volts or even 16 volts DC. This diode here is rated for 50 volts, so it's not going to burn out, and it's pretty cheap. So it's a lot easier than having to keep constantly replacing the lights if you get a surge, or you happen to max out the Loco or something like that. So it's just a good practice to put this diode in there to prevent the flow of electricity through the circuit in the wrong direction. Now the resistor here basically reduces the flow of current, basically drops the current through the circuit. And so what this is doing is, because the LEDs here are rated for about, I think it's 3.7 volts maybe, it's possible that we could get a lot higher voltage through that, more current through it. And so what we've done is by putting a resistor there, we're basically requiring more power to be pushed through to get the same level of brightness than if the resistor wasn't there. So if I turn this down a little bit, I've got the power on about 20% there, and there's no light. And so if I increase the power, it comes on. Now if the resistor wasn't there, I could have this on like maybe 2%, and it would go and light the LEDs, and they would be a lot brighter at higher levels. And so this resistor is basically protecting the LEDs from the forward flow. Now it doesn't block the flow of electricity, it simply absorbs some of it so that it doesn't get passed through to the LEDs. Now the LEDs here are wired in parallel, and what that means is basically the two connectors here on the positive side are connected to the resistor, and then the two negative sides are connected onto this other side of the diode, and they're basically just in line with each other rather than being back to back. And so that basically means they're basically being protected by both the components. You don't have to add any components in between or so on. Now if I wanted to have one light brighter than the other, what I might do is wire them in series, which basically means that instead of them being connected here and here, I might have them connected into the middle here, and then kind of daisy chained, and then that would allow me to put a resistor in between the two LEDs to reduce the brightness of one and not on the other. But since these tail lights need to be the same, I've wired them in parallel. So the flow of electricity is pretty simple. Comes from the positive side, and it goes into the circuit from the track, goes across the resistor, through the LEDs, out through the diode, and then back onto the track to complete the circuit. You have to complete the circuit. If the electricity can't flow from one side to the other, it's just not going to work. Now if I was to turn the controller in the opposite direction, so I turn it off and then turn it in the opposite direction, you can see it's the same level of power, but the lights haven't come on. And the reason the lights haven't come on is because the LEDs will only do power in one direction because they're diodes, and so the electricity is actually coming in the opposite direction. So it's coming in through this side, is now the positive side, trying to go across the diode, which it can't do because the diode's blocking it. If the diode wasn't here, it would, the other side would just flow through the LEDs, and it would stop because the LEDs act like a diode as well. So the only problem is the LEDs would take the brunt of the stopping power, and obviously that can lead to heat and so on, and you could potentially damage the LEDs. So putting this cheap diode in between the power and the LEDs allows this component to take the brunt of the stopping power. And what this is because the diode here is rated at 50 volts. Obviously the controller is never going to get that high, so this is pretty much like over-spec'd basically for the circuit, and so it's safe to use. It's not going to get too hot, and there's nothing that the power controller from the track is going to do to this diode that could damage it. So we're pretty okay with this particular circuit the way it is. So I'll walk through the other circuits, but they're basically the same thing. The other one's a little bit more complicated, and I'll explain that next. Okay, so this is the other circuit, and it's pretty straightforward. We have power coming from the track in through here. It comes across this wire into this 1 kilo ohm resistor, and then if you follow this wire over here, it basically goes into this breadboard, which is just jumpering it into this breadboard here. You can see this wire is connecting the circuits in parallel. So you have two 470 ohm resistors that are wired in parallel here. Now the reason these are 470 is we already have the 1 kilo ohm resistor in play at the start of the circuit, and then these are in parallel after this. So they're causing the current to drop a little bit more. Now, the reason we added these is these are one's for the headlight and one's for the side markers, and these side markers in the headlight are a little bit dimmer than what would be required if they weren't in there. So adding these two resistors is just basically getting the light level a little bit closer to accuracy. Now I may have to muddle around with these resistor values and to get it right once it's into Loco, but we'll work on that in a few minutes. So these are wired in parallel, and so you can see here they start off once here and once here, and they're connected into this side of the circuit that goes back over into this jumper board. This really wasn't necessary, but it's just there to make it easier to follow. and then it comes back in this side on the other side of the resistor, and it goes into the LED, out the LED, and then into this diode, and then it comes out here and goes back into the track to complete the circuit. So just like with the taillights, we have this diode here that's preventing the flow of electricity in reverse. So this diode is basically protecting all of the LEDs in the circuit. When we have this LED that's wired in series to these two here, and then these two are wired in parallel with each other, and they're protected not only by these two 470 ohm resistors, one each for each LED there, but also in this 1 kilo ohm here. Now if these were wired slightly differently, these two resistors would impact both LEDs and it would be dimmer, but for the way we have it right now, it's just wiring one. Now I can demonstrate this, and what I'll do is I'll remove one of the LEDs and replace it with, or sorry, LEDs, I'll remove one of the resistors and I'll replace it with a wire, and you'll see that one LED should then become brighter than the other. So if I get a jumper wire, we'll replace this, if you can see it on camera. Okay, I'm actually going to turn the light out so you can see the effect a little bit better. So you can see there I removed the resistor, and because I removed that resistor, this LED's brightness has stayed the same. This LED has gone out, and the reason this LED has gone out is because that resistor is no longer completing the circuit on that side, but these are in parallel, so it doesn't affect the other one. So if I take this jumper wire and jumper it in, maybe these things are a little, okay, so you can see there now that this LED is slightly brighter than that LED, and the reason for that is that we've removed this resistor. So because these are wired in parallel, the electricity going into the side of the circuit is the same, but when it flows through and it's two separate kind of prongs in the circuit, this one's impacted by this resistor, but because this one doesn't have that resistor anymore, it's not impacted by it, and obviously it's slightly brighter current. Now, one of the things that we're going to do is one of the sides has a headlight on it that's a little bit brighter. So what I'll probably do is I'll probably replace this 470 ohm resistor with maybe a 200 ohm or 220 ohm resistor, just so that one side is brighter than the other, to get that same effect without impacting the side marker. But you can see there, it'll give you the idea of how that works. Okay, so I just wanted to go through this one more time. This is the final adjustment before I put it into the Loco itself. I'm thinking I may add another resistor to the top light. I'm not sure yet. The top marker is a lot more subdued than this. It's actually a little bit too bright. So I'm thinking I may put the 460 ohm resistor in there to perhaps reduce that. But you can see I've got the headlight side that's going to be lit a little bit brighter, and I ultimately used a 150 ohm resistor. So circuit's just as before. I've got the 1 kilo ohm resistor at the start, but where the circuit goes off in parallel, we've got the 470 ohm resistor, and we've got a 150 ohm resistor. And the reason I wired it like this was just so that with it being in parallel, we can control each side of the light system right there, and then the top one is separate. Okay, so for the next stage, we're basically going to do a quick test. So I'm going to reassemble the Loco a little bit. This is the chassis basically. All I've done is I've rerouted the wires through this little plastic piece that's right here, and then I've replaced the foam adhesive strip, and now I'm going to put the DCC board here, socket board, back in. And so I'm going to oops, so get that to line up. And then with the other one started as well. Again, just line it up. It's a little more awkward when I have to do it on the left hand side because of the camera. Okay, so we have a couple of different options with what we could do here. So this here is normally where the Dcc plug, which is this, which is this piece of electronics here. It has a pin 1 mark right there, and I believe this is pin 1 here. So this would normally just go in like so, and go into the board. Now the problem is I want to tap into these pins to use for the lighting, but I also have to basically provide the same functionality this board is doing for the controller. So the best and easiest way to figure this out is to use a multimeter. So I'm going to put the multimeter on this setting here, which is the resistance. Then I go press it once, so it's on continuity, and then if I set it down there, you'll see that when I touch the two prongs together, it makes that kind of beeping noise. So what I can do now is I can see which pins here are connected to which. So if I touch pin 1, I can go down across the side and see, so I know it's connected to the first one, it's not connected to the second, it's not connected to the third, it's not connected to the fourth. It is connected to this bottom one here. Okay, so the one below it and the one opposite are connected. Now if I touch this one, I see those are connected, but it's not connected to any of these other ones. If I touch this one, I see it's connected to there and to there, but not to the others. These two are connected? Nope. So it's connected to those two. This one's connected to these two. Okay, so what I'm going to do is just write down how these are connected. I'm going to label them pins 1, 2, 3, 4, 5, 6, 7, 8. And you know, a quick way of doing this is to make sure it's on the pin. Sometimes you can get a bad connection, so it's worth checking it out. And then what I can do is I can pop this off like so, and then I can see which pins on the actual socket are connected together, because that will tell me if there's any connection within the socket. And it doesn't look like it. Looks like the socket's not connected in any way. Touches itself. No, you have to just be careful you're not touching the prongs against themselves. So I can then go and move the look right away a little bit and check the prongs on the actual board itself. And I just remember I have switched it, flipped it over. This can be somewhat tricky to do. So it looks like those two are connected. These three are connected right here. So now that I know which ones I have to wire together, I can wire those together as well as adding in the breadboard. So what I'm going to do, and it's kind of cheating a little bit, but I'm going to take this blue tack, and I'm going to use the blue tack to test the circuit. So we're done with the multimeter, so I'm going to turn it off, set it aside. But what I'm going to do is I'm going to blue tack this breadboard into the Class 66 chassis, so that I can do some testing on the layout before I solder things up and run it on the track in its final form. So I'm going to use these wires that I've been using for the baseboard, or sorry, for the breadboard. Got baseboard on mind here. So I can actually put those into those holes, and they should do a pretty good job of making a connection. So because I can do that, I can take some blue tack, secure this breadboard. It does have an adhesive strip, but I don't really want to stick this thing into my Class 66. This is just temporary. So I should be able to use some blue tack on the sides here to get it to stick. And it doesn't have to be pretty, it just has to stay put as it goes around the layout. It's for a test. Okay, so what I'm going to do is I'm going to go and wire this up real fast, and then we'll show it to you, hopefully working. Okay, so you saw there, it's working on the layout, and what I've done is I've blue tacked the mini breadboard to the locomotive here, and I've used some jumper cables, basically 3 connectors on this side, which is pins 1, 2, and 3 were all connected together, and then down the bottom here, there's a 3, 4, 5, 6, so it was pins 6, 7, and 8 were connected together. So 6, 7, and 8 are connected here, and they go through to the negative side of the circuit, and then 1, 2, and 3 are connected to the positive side of the circuit, and it's flowing through. So what's happening is you've got power coming from the Loco, going through here, flowing through the resistor, through the 2 LEDs, back over the diode, out this side, and back down into the track. And as you saw there in the clip, the 2 red lights came on in one direction and not in the other, so that part of it is working real well. So what I'm going to do next is, it's going to get a little cramped, but I'm going to reorientate this a little bit, blue tack in the other circuit, and just test that it works okay as well. And then what I'll do is, back on the workbench, I'll show you a closer look at how that's wired up. And then what I'm going to do, I was planning to solder this up and put it into the Loco. However, I found a better way of doing it, but the parts haven't come in yet. They're not going to come in until tomorrow. Unfortunately, Amazon Prime, they were supposed to get delivered today, but they did not. So I waited and waited. They said they were coming later in the day, but unfortunately they didn't. So I'd rather use those. I could solder this up and just show it to you running a Loco, but what we'll do is next week we'll show you the other solution, and I think you all agree that the other solution is probably a better way of doing it. Alright, so let me go and test out the white lights, and then we'll show you the whole thing on the workbench and go through the circuit one more time so you can see. This is actually a very handy way of testing adding lights and electronics to the locomotive. It's making use of the DCC socket and the breadboard to do some electronics testing and prototyping. Okay, so earlier in the video I mentioned that we wired pins 1, 2, and 3 together because that's what the continuity tester showed us with the Dcc plug. And so you can see here what I've done is I've wired them over into this section here. So on the breadboard, these rows here, so on the breadboard this row and these are separate. So these are all wired together and these are all wired together, and then this break down the center separates both sides. And so each row on the breadboard is essentially wired up individually. So what I've done here is we've gotten one connection from pin 1 and it's going over here, and then there's a jumper connection from that group over to here, and then we've jumpered back pins 2 and pins 3 because they're all connected. But then we've also wired this into the negative side of the front lights and into the positive side over here of the rear tail lights. And so basically what's happening is when the positive side is positive going in one direction, it's going to go in light tail lights, and then it's going to get blocked off by the diodes in the other circuit. And then when we go the other way, it's going to get blocked off by the diode in this circuit, and it's going to light the lights in the other way. And so you can see here the other side of the circuit was pins 6, 7, and 8, and 6, 7, and 8 are wired into here and then jumpered into the reverse end of this circuit and the forward end of the circuit over here. So the two circuits are basically the same as the ones we discussed earlier. I just simplified it a little bit so it would fit on 2 baseboards and fit obviously onto the Loco. And so this is how we're going to wire it up in a more condensed way in the next video, and you can see it then embedded inside the train itself. And so the way we're going to do that is there's 2 options. We could take some Vero board like this that I blackened in the previous video, and we could do that, solder it up that way, and maybe cut it into strips. However, I was looking on Amazon the last couple of days, and I discovered that they sell really small breadboards. And so I think I'm going to do that. There's a big space here for, I think, a sound speaker, and I think I can cleanly wire all these things together so that they fit in that baseboard or in that breadboard. I will probably wire the lights into their own wiring and then wire it into the baseboard that way, or into the breadboard that way. But basically, I'm thinking this will make it easier to expand later, and have a couple of ideas on how to expand it later on. So for this project, I have some pretty cool ideas in mind. So I'm going to go and use the smaller breadboards to wire it in, so that we can expand it in an upcoming video. Okay, so you can see here when it's traveling in this direction, the lights are on, and when it's traveling in this direction, the lights are off, which is fine. But what we wanted to test was that my theory would work, that if we pick the Loco up and flick it around like this, if I pick it up and I put it the other way, then what we wanted to have happen is that the lights would work in the opposite direction, which they should. So let's test that out. So if I run it the opposite direction, you can see there the lights are on, and then if I run it back this way, the lights are now off. So what that's going to give me is the ability to pick the Loco up and flick it around and have the lights work in different directions. So what I'm going to do next is I've simplified down this into 2 breadboards. It's going to get a little crammed in here, but what I want to do is basically just show you guys how it works here on the thing, so we can make sure it works okay, and then we'll in the next video break it down into a completed finished product. And like I said earlier, I have found a couple of cool things on Amazon the last couple of days that would actually allow us to do that a lot cleaner. And so rather than soldering lots of stuff up and kind of trying to make it cram and be a little messy about it, I'd rather go the other way because there's some advantages to it, and it will let us do a very cool follow-on project as well. So I'm not sure if you can see there, but the two red lights are coming on when we push it that way. The breadboard's having a bit of an issue. But you can see there, all three front lights are coming on. So that connection issue with the other one is red lights, basically just a breadboard, and it's because of the LED legs are a little flimsy. I'll see if I can fix it real quick. It's hit or miss whether you can fix it or not. Basically it just needs to be reseated in the, yeah, there it goes. Alright, so if I bring this around, we'll give you guys a quick look at the thing on the workbench. But what I've done basically, as you can see here, is I've got the three breadboards all on here as one circuit, and it's all tested together. It looks crazy, but it's actually a good way to test it. This way I can make sure it's working okay before I go ahead and solder anything up. So it's definitely a good approach, and it makes its way around the layout more or less pretty alright. But as you can see there, it's tested out perfectly okay. We've used the breadboards, so we haven't had to actually solder anything yet. We've been able to just plug and play and make sure the thing works. And this is a fantastic way to troubleshoot and you know, try out new circuits and maybe even try some new electronics projects with your 00 scale Loco. Okay, so that's it for today's video. We're making pretty good progress with the circuitry and the electronics. You can see there it's working pretty well. So like I said earlier in the video, the next video we'll have some stuff in from Amazon that'll let us kind of cleanly install these circuits into the Loco. I'll also wrap up some of the 3D printing work. I know I need to paint and add the 3D printing parts here for the roof, as well as the part here that needs to get installed for wrapping up the exhaust slash silencer here that's on the roof that we 3D printed in the other video. Alright, so I hope you guys enjoyed it. If you have any questions or suggestions, please feel free to leave them in the comments below. And until next time.